Well, this video is for Math 116 for section 1.7, and this is the section on composite functions. So composite functions are two functions together where one function is acting on the other function. So let's talk about this. So the example I give in the textbook here on page 42 is, let's say that we've got a function f of x equals 2x minus 7 to the third power. So one way of thinking about this is as a composite function. Let's say we've got two separate functions. Let's see. G of x as 2x minus 7 and h of x as x cubed. Then you can think of our original function f as a composition of these two functions. Okay? So what I'm saying is that you can think of f of x as being h of g of x. Okay? If you remember, and I think it was the first section in chapter 1, where I asked you to find, let's say, h of 2x minus 7, right, where h was a particular function, and you would just take this piece and plug it into the function itself, and that would give you the 2x minus 7 to the third power. So here, instead of using the actual function itself, we just use the function name g of x. All right, so that's the idea behind composite functions, is that it's one function acting on another function. I like to use the parentheses so you can see, oh, just take that g of x and plug it in wherever you see an x in the h function, okay? Or you can use the actual function itself, and that'll generate this expression right here. Oh, the other notation for this, besides the parentheses notation, is this little circle notation, h on g of x, that indicates oh wait, I've already got that one. There we go. That indicates a composition of functions, and it'll give you the same things that this does. I found that people are more confused by this, but it's a valid notation, and it's used a lot in textbooks and in classrooms all over the country. So that's the basic idea behind the composition of functions. There's a couple reasons why we talk about this. In studying the ideas and concepts behind functions, this becomes an interesting concept, and it has its place in that overall approach to thinking about functions. The reason why I'm talking about that, I've seen courses where they kind of dig into functions in a more abstract way, and this composition of functions has a place in that consideration. And then the other reason why we talk about this is in calculus. The processes of calculus that you do to typical functions have a particular rules to follow if you're working with a composite function. Okay? And so if you end up taking a calculus course, you will see that. And so recognizing a composition of functions is a very important part of this. So let's look at some of the exercises here. The first set from 1 through 6, I give you two functions and then ask you to write down the composition of these functions. In the next set, I'm asking you to recognize a composition of functions and then just sort of decompose them. So let's take a look at these. In problem 2, we've got f of x is absolute value x minus 3, and g of x is 2x plus 3. So we want to find f on g and g other notation above that f of g of x, and here g of f of x. So in both notations, whatever's to the right gets plugged into whatever's to the left, right? This is inside the parentheses, but it is to the right there. This is going to get plugged into f. Here, the f is going to get plugged into g. All right? All right, so here, if we take the g and plug it into f, let's see, maybe I'll do a step before that. Let's do that. Absolute value g of x minus 3, and then actually write out the g of x function, and we end up with absolute value 2x. Okay, so here we're going to have 2 times f of x plus 3. So that's 2 times x minus 3 plus 3. And you can't really do much besides that. You can't just get rid of these absolute values and act like they're parentheses, because they're not. And so this would stay the way that it is. And in doing this, I think that we can see that composition of functions is not commutative. F on g and g on f typically give you different answers. Sometimes they'll give you the same answer, and sometimes they won't. Okay. All right, let's look at problem 4 here. X cubed minus 1 is f of x, and g of x is equal to 1 over x cubed plus 1. Okay? Let's see here. So, f on g of x, that means take the g and plug it in here. And there's not a whole lot that we can do to that. Raising this thing to the third power I don't think is going to be really fruitful for us. So let's just go on and take a look at g on f of x. So we'll take the f, plug it in here, and then put in the actual function. X cubed minus 1, all cubed, plus 1. You could cube this out if you want to. This one is a little bit more ripe for some simplification than this one was. But in this case, I would just leave it like this. Okay? Anytime this goes beyond a 2, then I would just leave it alone. But if it is just being squared, you might as well multiply it out and see what it looks like. Okay, let's look at problem 6. Problem 6, f of x, 2x cubed minus 1, g of x is the cube root of x plus 1 over 2. All right? So, f on g, oh, I erased the other notation. I'll go ahead and put that back up. F on g of x. So we take the g and we plug it in here. 2 times g of x to the third minus 1. So that's 2 times cube root of x plus 1 over 2 to the third power minus 1. Now, having just said that raising something to the third power isn't typically going to make things simpler, you're taking a cube root here and you're raising it to the third power. Those two things are just totally going to cancel each other out. This will be 2 times x plus 1 over 2 minus 1. Those cancel out. And that leaves us with x. I think I've set these up so that these two functions are inverses of each other. And that's actually one of the definitions of an inverse function, is that f on g will give you an x back. And so will g on f. So let's double check that and see if we go the other way, do we also get the x? And that'll tell us that these two things are inverse functions, which we'll see in the next section, 1.8. All right, so g on f, what are we going to get here? Take the f and plug it in here. So this is going to be the cube root of, first I'll write it out as f of x plus 1 divided by 2. Okay. So then it's the cube root of 2x cubed minus 1 plus 1 over 2. And then these minus 1 and plus 1 will make 0. Then the 2's cancel out. Cube root of x cubed is x. So these two, I think I did this on purpose, these two are inverse functions of each other, and in that case when we do f on g or g on f, in both cases we get an answer of x. But if they're not inverse functions of each other, then, oh, let's see here. Looks like I stopped here before I did g on f. But anyway, if they're not inverse functions of each other, then they typically won't give you the same answer. Okay, well let's look at g on f then, since I didn't finish number 4. Let's do this in red to give us some space here. G on f of x, that means take the f. Let's see, oh, I already did that. Oh, there it is. Oh, that's where it is. Okay, I got so confused because I was doing these side by side, and then here I did them one after the other. All right, so there we go. Well, let's continue on here and then look at these problems where we just have to recognize composite functions. Okay? And these are open to interpretations. There are multiple correct answers for these problems. So let's take a look at them and hopefully you'll see what I'm saying in that situation. So h of x in this case is x squared minus 2x to the third power. Okay, well we could call this, let's see, we want to make this h of x equal to f on g. Okay, so a lot of times when I'm teaching calculus, I call g the interior function and f the controlling function or exterior function, all right? So here, the interior function is x squared minus 2x. So we could say g is x squared minus 2x. And then the controlling function f is x to the third power. Okay? And so then if we do f on g, plug this in here, we'll get h. Okay. Problem 10, cube root of x squared minus 1. Very similar, the interior function, the g, is x squared minus 1, and the exterior function, or controlling function, is the cube root function. Let's see here. Let's look at problem 14. Here we've got h is equal to 1 plus 1 over x to the minus 2 power. Okay, so the interior piece is the g function, 1 plus 1 over x, and the controlling function is x to the minus 2 power. All right. Let's look at one more here, problem 20. Our composite function h is negative 3 over x minus 1 to the 5th power. So our interior function g is 3 over x minus 1, and the controlling function f, negative x to the 5th power. Okay, so that's it for composite functions. Like I said, there's a lot more that you can do with this topic, both in the abstract, which you may or may not run into in a higher level math course, or in calculus, where it becomes really important to recognize composite functions. Okay? So that's it for section 1.7. As always, if you have any questions, please let me know. Thanks.